Hello everyone. My name is Kunal, and I'm your mathematics tutor. And currently, we are doing our differential equation. And today is our the seventh lecture on differential equation. So, in previous class, we actually deal with some exact differential equation and Bernoulli equations, which is nothing but reducible to LDE. That means linear differential इक्वेशन राइट तो हमने प्रीवियस क्लास में ये सारे इस पे थियरी पार्ट कवर कर चुके थे सो लेट मी स्टार्ट विद सम क्वेश्चन क्योंकि हमने इम्प्लीमेंटेशन देखी नहीं थी सो लेट्स बिगिन टुडेज लेक्चर व्हिच आई एम ऑलरेडी टेल यू कि मोस्टली बेस्ड ऑन practice like how to basically in this lecture we are going to learn how to implement the theoretical part which will already cover in the previous lecture. So let's begin with the first problem. Okay, so this is our example number 1. So, okay, our first problem is something look like dy by dx is equal to y by x plus y square by x square. Okay, so actually we have to find the actually the general solution of this differential equation. So how to proceed? Right. Is this in the form of linear differential equation? So first try to figure it out. What is the form of the LDE? The form of LDE will be like dy by dx plus something there px is written, there y is written, and there will be some q is a function of x. But this is actually the mixture of x and y. So of course this is not the LDE. So we have to this is actually the Bernoulli equation, so we have to convert this into the LDE. So let's try to do. So what can I do here is, I just divide it by the maximum power of the y here. Okay, so we can write this equation as 1 by y square. I just divide LHS and RHS by the maximum power of y, which is actually here is y square. Okay, so I'm just dividing here LHS and RHS by the y square. So what we will get 1 by y square dy by dx, and take this side, take this value as well as on left side. So what we will get? We will get minus 1 by y into x is equal to 1 by x square. So this we will get as a function of x, and this we will get as a function of y and x as well. So what I have to do here is, I have to just let minus 1 by y is equal to t. So when and differentiate this, differentiate with respect to x only. So what we will get here? We will get 1 by y square or dy by dx is equal to nothing but dt by dx. So we can write this whole term as dt by dx. So let me call it equation number 1. So now from equation 1, actually 1 by y square dy by dx, we can write it into dt by dx. So there will be write it as dt by dx and minus 1 by y as dx, and there will be 1 by x square. So this equation actually in the form of linear differential equation, because this is actually in the form of something dt by dx plus something, there is a function of x, there will be t, and there is a function of x as well. So this is actually, this equation is in the form of linear differential equation. So now we know how to proceed on. We have to find the integral factor here. So the integral factor formula will be e to the power integration of px dx. So it will be equal to integral of what is the px here? There will be x dx. So it will be equal to e to the power x square by 2. Right. I hope this thing will clear to all of you. I did some mistake here. Okay. There will be 1 by x and I taken as x. Sorry for some error here, because there is 1 by x. Huh? 1 by x. Look at here. This is actually 1 by x. So as I convert the 1 by y, I substitute t. So I thought there will be x in numerator. So it's my bad. So the integral factor will be changed here. Actually, our integral factor is now, there will be 1 by x dx. So the integration of 1 by x, all you know is ln mod x, so it will be x. Okay, so this is our integral factor. Now the solution. Now we're talking about the solution of differential equation. The solution of differential equation is, we know that linear differential equation is y. Basically here is not y, here will be t. So we can write here will be like t into integrating factor is equal to integration of qx into integrating factor dx. So here will be t and integrating factor is nothing but x. And we have to, what's our qx is? Our qx is nothing but 1 by x square. So 1 by x square and integrating factor is x dx. And we all know that the integration of 1 by x is ln mod x plus some constant. And when we put the value of t here, which is actually the minus x by y is equal to ln mod x plus c. So actually this is our the general solution for the given differential equation. So actually you have to write it here. So let me write it here. So the general solution of given differential equation, this is not, the given differential equation is not the linear differential equation. We actually convert those given differential equation into LDE, right? So the general solution of the given differential equation is minus x by y is equal to ln mod x plus c. Okay. Now let's take the next question, which is actually written in Word. So let me write it here. Example number, I don't know. I think it's good start. So if a curve passes from 1 comma minus 2 and has a slope of a tangent at any point x comma y on it as x square minus 2y by x. Then find the curve. You have to actually find the equation of the curve and find the curve or equation of curve, whatever. Look at here. Actually हमें दिया हुआ है कि एक एक कर्व है, ठीक है. पहले क्वेश्चन को समझते हैं. ये एक कर्व है. I don't know how it's look like, but let us suppose this is something our curve, and it's passed through the point 1 comma minus 2. Okay, and किसी भी मतलब किसी भी x पे अगर अपन बात कर रहे हैं, यहाँ पे किसी भी x पे अगर अपन बात कर रहे हैं, तो its slope will be like slope क्या होती है हमारी dy by dx. तो उसकी वैल्यू ये है. The slope will be x square minus 2y by x. And now we all know that how to solve the differential equation, right? And there is a actually the value of the function is given. So the we didn't get the general solution. We get the particular solution here because the value of the function is given here, right? If the value of the function is not given, so we get the family of the curve. मैंने आपको पहले बताया था कि what's the differential equation represent the geometrical interpretation. So it also represent a family of curve which have same property. So I am telling you here if we get the actually equation of curve in a particular value which has a basically distinct from the other one. Okay, so let me try to solve this differently because listen here, there is actually a differential equation, but is it in the form of linear differential equation? So let me check by simplifying it. So dy by dx is equal to x. We can divide it by x and minus 2y by x. So here we will get dy by dx plus 2 by x into y is equal to x. Yeah, it is. Because it is in the form, it is actually linear differential equation because it is in the form of dy by dx, because it is in the form of dy by dx plus something px into y is equal to qx, right? It is in the form of that. So what we can do here, uh, we have to find the integrating factor here. So integrating factor will be nothing but e to the power px into dx. We have to integrate, right? So e to the power, when we integrate the equation, which is actually given 2 by x or dx, so we will get e to the power 2 of ln mod x. So its value will be nothing but x square. So our integrating factor is nothing but x square. Now the solution of differential equation, which is given actually, which is LD, this is actually the linear differential equation, is y into integrating factor is equal to, we have to integrate the integrating factor into qx is with respect to dx. So here qx is nothing but x. So what is integrating factor? X square. And what is our qx? Qx, I think x. Okay, okay. So dot x dx. So what we will get here? We will get x square y is equal to x to the power 4 by 4 plus some constant. Okay, so this is our actually the general curve. General solution, or we can say that the family of curve. But we have to find a curve which passing through this point. That means f of I think f of 1 is equal to minus 2 is here given. That means for x is equal to 1, the value of the function, the value of curve is minus 2. So let's try to put it here. So there will be like, put the value of x is equal to 1. So 1 into minus 2, because we get the value y is equal to minus 2. And there will be 1 by 4 plus k. So here we will get the value of k will be minus 9 by 4. Right. So the equation of curve is nothing but x square y is equal to x to the power 4 by 4 minus 9 by 4. So this is our the equation of curve. So look at here. हमें यहाँ पे डायरेक्ट सॉल्व नहीं करनी थी, ठीक है? हमें यहाँ पे डायरेक्टली सॉल्व नहीं करना था, हमें पर्टिकुलर सोल्यूशन चाहिए थी, ठीक है? तो वही एक्चुअली इक्वेशन ऑफ कर्व होगा, बिकॉज वी ऑल नो दैट ज्योमेट्रिकल इंटरप्रिटेशन ऑफ डिफरेंशियल इक्वेशन व्हिच इज एक्चुअली रिप्रेजेंट द फैमिली ऑफ ए कर्व व्हिच हैव कॉमन प्रॉपर्टी, राइट? तो यहाँ पे अपन वही कर रहे हैं कि देखो यहाँ पे कर्व दिया हुआ है, कैसा भी कर्व होगा, आई डोंट नो its equation and how it's look like. So by assuming that is something this is our curve equation, and इसकी जो भी slope है ना, जो भी slope of tangent है किसी भी x and किसी भी y पे, किसी भी x and किसी भी y पे वो है something like x square minus 2y by x. Okay, and actually then the equation of the curves हमें निकाल लिया है, ठीक है? तो the slope of the is given like x square minus 2y by x. So we are calculating here, this is actually linear differential equation. And when we are calculating solving the linear differential equation, we will actually get the following result. And here we get the general solution, but actually the value of the function is given. So we get the equation of the curve here. So the equation of curve is something but look like x square by 4 minus 9. So we can write this into something like that. Y is equal to x square by 4 minus 9 by 4 x square. Okay, so this is our equation of curve. Okay, so our next problem is something dy by dx. Example Okay, so it will be look like dy by dx is equal to y by y square plus x. Okay, so actually we have to find its general solution. Find the general solution for differential equation. Okay, so actually we have to find the general solution. So first we have to look into is it a linear differential equation? Okay, or not. So let me check it here. So what we can do, we just simplify it, or we can do something more, but let me try it here. So what we can do, we can reverse this equation. Okay, so take the reciprocal, because we all know that like dy by dx is equal to 1 by dx by dy, no change, right? So I just, what I'm doing, dx by dy is equal to what we get, y square plus x by x, y. That means numerator become denominator and denominator become numerator. Now what I have to do here is dx by dy divided. So what we will get? We will get y plus x by y. Okay. So here we will be get x by dx by dy minus x 1 by y is equal to y. So actually this is a linear differential equation. So why I am telling this is a linear differential equation, because we all know that the linear differential equation is look like this. Either it will be written in form of dy by dx plus there is a p as a function of x and y and is equal to q as a function of x, or dx by dy and q as a function of y into x is equal to, or we can say p as a function of y and q as a function of y. So both are linear differential equation form. We already discussed this thing, right? So actually this linear differential equation is of the form look like this. Okay. So we all know that actually this is an linear differential equation. So what we can say? We can say we have to do, we have to find the integration factor. And what is the integration factor will be? It will be equal to e to the power py dy, right? Something changes here, right? First, we are integrating in e to the power px dx. Here we'll be integrating py dy. So what is our py? Py is our nothing but 1 by y. Actually, minus 1 by y. Okay, so there will be minus 1 by y dy. And we all know that the integration of this will be ln y. So it will be equal to ln y mod of y. So it will, we will get minus y. Actually, this goes in here. So we'll get 1 by y. Sorry. This is a basic logarithmic property. I hope you're all familiar with. The power goes in, the sign goes in power. So 1 by y. Now the solution. Now talking about the solution of differential equation. So it will be equal to x into 1 by y. Just we are writing the x into integrating factor. Let me write it here first. Then we are gonna write the equation. Then we are gonna write the solution. So our solution is nothing but x into integrating factor is equal to integrating factor into qy dy. So x into 1 by y, integrating factor is 1 by y, and our qy is, okay, y. That's the easy calculation we get, right? So here will we get x by y, and there will we get y plus some constant. Okay, so this is our this is the x by y. X by y is equal to y plus k is the general solution for given linear differential equation. Okay. Okay, now let's move on to some tough problems, and then we learn the implementation of exact differential equations. So the next problem is example. So actually what you have to learn here is कि what I am doing. देखो कोई प्रॉब्लम हो रही है कि डायरेक्टली लीनियर डिफरेंशियल इक्वेशन के फॉर्म में आ रही है, कहीं पे अपन सीधा नहीं कह रहा कि इक्वेशन को कि इसके सोल्यूशन चाहिए, कोई कह रहा है मेरे को कर्व की इक्वेशन चाहिए, तो कर्व की इक्वेशन कैसे निकल रही है? बाय सॉल्यूशन ऑफ लीनियर डिफरेंशियल इक्वेशन, राइट? सो आपको समटाइम्स क्वेश्चन में क्या करेगा ना कि वो डायरेक्टली नहीं बोल रहा होगा कि सॉल्व दिस डिफरेंशियल इक्वेशन, वो ऐसा कुछ बोल देगा कि लाइक कर्व की इक्वेशन निकाल दो, या फिर एरिया निकाल दो, या कुछ भी ऐसा। अभी और आगे इसकी इम्प्लीमेंटेशन देखेंगे ना, तो और चीजें क्लियर हो रही होंगी। तो चीजें ऐसी बोलेगा, लाइक इस क्वेश्चन में हमें बोला कि इक्वेशन ऑफ द कर्व बताओ, तो हमें निकालनी थी ना इक्वेशन ऑफ कर्व by using the method of finding solution of differential equation. Okay, so this is actually the thing that we have to read. Now let's move on to the next problem, and it's something look like dy by dx, or dy by dx plus x into sine 2y is equal to x cube cos square y. Okay, so let me try to my suggestion is to pause the video and try to solve it by one, because these are standard problem. Okay, so if you solve this problem, so your confidence will be automatically rise, right? So my suggestion is to pause the video and try to solve it by own. अगर नहीं हो रही then watch the solution. मैं तो solve कर ही रहा हूँ. Okay, so look at here, this is actually not the linear differential equation form. Why? Because our LDE is form is dy by dx plus something p as a function of x into y is equal to q as a function of x. बट यहाँ पे लिखी नहीं हुई है, यहाँ पे समथिंग, यहाँ पे कुछ y वगैरह भी नहीं है, इंडिपेंडेंट हमें y चाहिए, यहाँ पे साइन टू वाई वगैरह कुछ कुछ लिखा हुआ है. सो दिस इज एक्चुअली हमें बर्नौलीज इक्वेशन की ही यूज करनी होगी, हमें इसको रिड्यूस करना होगा लीनियर डिफरेंशियल इक्वेशन के फॉर्म पे. सो व्हाट रूल क्या कहता है कि वी हैव टू डिवाइडेड बाय द मैक्सिमम पावर ऑफ द y, और जो भी y का फंक्शन है. So this is the maximum power of the y function, which is cos qy. So cos square y, right? So divide the LHS and RHS by cos square y. So what we will get here? We will get look at the here 1 by cos square y dy by dx plus we can write sin 2y as 2 sin y cos y. So let me write it here, 2 sin y cos y by cos square y into x is equal to x cube. Okay, so here will we get q as a function of x, right? So if let me solve it here. So we will get 1 by cos square y dy by dx plus 2 sin y 2 tan y into x is equal to x cube by x cube. If we assume, assume or let, if we let t is equal to tan y, and we differentiate with respect to x. So dt by dx is nothing but sec square y dy by dx. That means this whole term is, we can write it into form of dt by dx. If I substitute t is equal to tan y. ये क्लियर हो रही नहीं हो रही? अगर मैं बस tan y को t सब्सिट्यूट कर देता हूँ, सो क्या हो रही है कि dt by dx will be sec square y dy, राइट? वो पूरे टर्म को अपन dt by dx लिख सक रहे हैं, है ना? Okay, so now on, what I'm gonna do here is let's move on to this equation. So it will be like dt by dx plus 2x into t is equal to x cube. Now, this is actually the our favorable linear differential equation form, right? यही तो है अपना linear differential equation की form. Okay, so now on, but like we have to solve this equation. So what we have to do, we have to just find the integrating factor here. So let me try to find it here though. The integrating factor of given differential equation is nothing but e to the power px dx. So when we integrate e to the power 2x dx, so what we will get here, e to the power x square. So this is actually our integrating factor here. Now the solution of differential equation, linear differential equation, is nothing but y into integrating factor is equal to integration of qx into integrating factor into dx. So y integrating factor e to the power x square, e to the power x square, and integrating factor is nothing but sorry, the qx is nothing but x cube. dx. Okay. So we all know that we can apply here like this is actually a direct integration, right? If we assume e to the power x square as something, so it will be solvable. So here its integration will be nothing but 1 by 2 e to the power x square minus 1 plus some constant is equal to y into e to the power x square. Okay. So I think there I have to change the variable by t because we substitute here by something. So let me change this variable by t. So what I substitute here, the value of t is, let me, so okay, we substitute by tan y. So here will be get tan y e to the power x square is equal to 1 by 2 e to the power x square into x square minus 1 plus some constant. So this is our general solution for given differential equation. Okay. ये सारी आपको डिफरेंट डिफरेंट फॉर्म की हैं इक्वेशंस हैं. सो इसमें चीजों को आपको समझना होगा, ठीक है, कि चीजें चल कैसे रही है. दिस इज एक्चुअली इन द फॉर्म ऑफ बर्नौली इक्वेशन. सो आई एम जस्ट कन्वर्टिंग दोज इक्वेशंस इनटू हमने किस फॉर्म में कन्वर्ट कर दिया, रेड्यूसिबल टू लीनियर डिफरेंशियल इक्वेशन के फॉर्म में बाय एलिमिनेटिंग सम टर्म जिसको हमने कुछ सब्स्टिट्यूट करा एंड डिफरेंशिएट करके वही टर्म आ गई. Okay, so now on, let's take the next example, and then we move to the exact differential equation implementation. So the next problem is something x dy. Okay, let me write it here. Yeah, something is x dy by dx plus y ln y, okay, is equal to x y e to the power x. So look at this problem. Is it in the form of linear differential equation? Obviously not, because there is no, actually it is written in dy by dx, but there is no, and the y is not even independent, right? This is written of ln y function, and there is also not proper written qx. So what we have to do, just divide it by the maximum power of the y, which is actually 1. So divided by, and divided by x as well, so we can get in an easy form. So divided by 1 by y dy by dx, x and y as well. So here we get 1 by x ln y is equal to t to the power x. Now just what you have to do, just take ln y is equal to t. Substitute or late. And when we differentiate this equation, so what do we differentiate with respect to x? So what we will get? We will get 1 by y dy of dx is equal to dt by dx. So here we will get dt by dx plus 1 by x, and there will be get t is equal to e to the power x. So now this equation is in the form of linear differential equation. So now we have to find its solution. So we have to find the integrating factor. Integrating factor is equal to nothing but e to the power integration of px dx, which is our px is our 1 by x dx, and we all know that it will be equal to x. Now the solution of differential equation, solution of linear differential equation will be nothing but I think there is some Wi-Fi issue. Okay. So the solution of the differential equation is nothing but what is it? There will be substitution, right? So t into integrating factor is equal to integration of qx into integrating factor dx. So there will be t, and integrating factor will you get is x, and the value of qx is e to the power x. So x into e to the power x dx. This is actually a simple problem. We can solve by using by parts. So here now substitute the value of t here. So it will be get ln y x ln y is equal to by using by parts here. and why Euler rule? You all are familiar with this. So we will get e to the power x and x minus 1 plus some constant. So I think like these are the enough practice for linear differential equation problems. And I hope you'll all understand this, how to solve those kind of problems and all. So I'm thinking I have to move to the implementation of uh, exact differential, right? Because हमने काफी कुछ कवर कर लिया है, लाइक लीनियर डिफरेंशियल इक्वेशन को कैसे या फिर बर्नौली को कैसे सॉल्व करते हैं. सो आई एम थिंकिंग कि लेट्स मूव ऑन टू द नेक्स्ट प्रॉब्लम, मतलब नेक्स्ट इम्प्लीमेंटेशन थिंग. सो ओके, let's try to do some problem based on. So first try to add some more point here, some more exact differential, okay? And then we are gonna learn its implementations. So the, wait, okay, so the some more linear differential equation, some more exact differential equations, which is actually I think हमने 6 लिख रखा था, so it will be 7. It's exactly x dy minus y dx divided by x square plus y square. This will equal to d of tan inverse of y by x. Actually, we are going to prove this thing जैसे हमने कल करा था ना. These all are one liner proof, क्योंकि इसमें कुछ खास है ही नहीं. Okay, so the next thing is y e to the power x dx minus e to the power x dy divided by y square is equal to d e to the power x by y. फिर x dy plus y dx divided by x square plus y square is equal to d of minus of xy. So these are some exact differential equation that we have to actually try to remember. No, मतलब याद नहीं करनी है, but ऐसा practice करते करते ना चीजें अब खुद ब खुद ध्यान में हो जाएंगी. So let me try to prove this. So how we can prove this equation? So देखो, इसको अपन क्या लिख सकते हैं, इसको लिख सकते हैं ना x dy minus y dx divided by just divided by, like, take the common x square. So what will get 1 plus y by x square. And we all know that the differentiation of this part is written here and here as well. So this is actually nothing but d of y by x is equal to 1 plus y by x whole square. And we all know that the integration of this is like dx by root under 1 plus x square is nothing but tan inverse of x. So this is going to prove. Same thing written will be here. Now let's move on to the last proof, which is actually here is d of xy here divided by d of xy square is actually xy square is equal to, look at here. So we can write this into like minus of d of minus 1 by xy, right? So these are some simple proofs. So now let's move on to the implementations part of today's lecture. Will be something like, let's see. Okay, so let's try to do some problem here, which is actually, look at here. First, solve the following differential equation. It will be first like x dx plus y dy is equal to x dy माइनस वाई डी एक्स वाई। देखो इस तरह की प्रॉब्लम ने पहले भी कवर कर चुके हैं, राइट? कैसे कवर किए थे? बाई पोलर सब्स्टिट्यूशन, लाइक एक्स को आर कॉस थीटा, वाई को आर साइन थीटा रख के सॉल्व कर चुके हैं, राइट? So we can do by some other method as well. So let's try to look at it. So what we can do here is, uh, this is actually written like d of x square plus y square and divided by 2 is equal to x dy minus y dx divided by x square 1 plus y by x whole square. Look at it. I just tried to convert it into this form, seventh form, right? I just try to convert this into this form. Look at here. Let me try to zoom out here. Okay. So I think it will be visible to all of you. So मैं बस क्या कर रहा हूँ ना, मैं इसको इस फॉर्म में कन्वर्ट करने की ट्राई कर रहा हूँ, and nothing more. Okay. Are you getting me what I'm trying to say? I just try to convert this equation into that form. Now, what I can do here is, we all know that this is actually the integration of differentiation of, इसकी integration जो होगी वो क्या होगी, 1/2 x square plus y square, और this is the differentiation of this, and this whole form is the actually, if you look at here, this is actually the d of tan inverse y by x. So here will we get integration, we will get tan inverse of y by x plus some constant. देख रहे हो कितने डायरेक्टली हो जा रही है भाई ये, by using direct integral form. Okay. Now let's move on to the next question. Question 2. It is something look like x y to the power 4 plus y dx minus x dy is equal to 0. Okay, so actually we have to calculate this. So what we can do is one more thing, like divide this both equation by y to the power 2. So actually I'm trying to do here is divide these equations by 2. So what I'm getting here is, if you divide this equation into two parts, so there will be like d of x square plus y square divided by, sorry. Actually, I do one mistake here. Y square. We have to write here the y square. So now on, what we can do here is, we can do x y to the power 4 by y square dx plus y dx minus x dy by y square. This is actually what is written here is. This is nothing but d of x by y. And here will be get x cube dx, and here will be get x by y square is equal to 0. Okay. So now on, we have to integrate this. So what is the integration of this both? So we'll get x to the power 4 by 4 plus, so this integration will be like x by y cube into 1 by 3 and plus some constant. So you have to learn this transition कि यहाँ से यहाँ अपन आए कैसे. So y square से पहले हमने divide करा. So we will get x y square here dx plus, this is the clear term, like this is actually written dx of x by y. Now यहाँ से यहाँ का जो transition था वो, let me show you by one thing. This is actually important. This is actually written like x to the power n dx plus x by y to the power m dx by y is equal to 0. So we can write this form into like x to the power n minus m dot y to the power m and dx. Then what I have to do is just write, we have to write like dx by y. So the same thing I'm gonna do here is, there will be like, we have to convert this form into this form. So what we have actually here, we have like xy square dx, and there will be like d of x by y. So what I'm going to do here is we get like n minus m value 1 and the value of m is equal to 2. So we can write this equation as x to the power n. So on calculating here, we will get n is equal to 3. So we can write x cube dx plus xy to the power m. And here m is nothing but 2 and dx by y. Okay, so via this transition, this is actually important. So take it as remark. Okay, so these are the things that we do here. So, okay, guys, that's all for today. In tomorrow's lecture, we are gonna deal with trajectories. Trajectories are basically, let me tell you something. Like ऐसा सुना होगा कि ये सन है एंड ये अर्थ है, ठीक है, ये सन है एंड ये अपने ऑर्बिट में से घूम रहा। तो एक्चुअली हमें निकालनी है पाथ की इक्वेशंस, ठीक है। ये इस ट्रेजेक्ट्री को फॉलो करा, सुना है ऐसा कभी? लाइक ये जो कोई भी सैटेलाइट है, कोई भी सैटेलाइट है, तो वो जो है एक ट्रेजेक्ट्री को फॉलो कर रहा है, एक पाथ को फॉलो कर रहा, ऐसा कुछ तो पाथ को ऐसा वो फॉलो कर रहा है, वो एक कंटिन्यूअस पाथ को फॉलो कर रहा होता है ना। तो दैट्स व्हाई आई एम सेइंग कि हमें वो ट्रेजेक्ट्री की इक्वेशंस कैसे फाइंड करनी है। जैसे आज हमने फाइंड इक्वेशन ऑफ कर्व फाइंड करा था, तो सेम वाइज कुछ ऐसा ही होता है जिसमें अपन ट्रेजेक्ट्री की इक्वेशन फाइंड कर रहे होते हैं एंड समथिंग लाइक ऑर्थोगोनल ट्रेजेक्ट्री, आइसोगोनल ट्रेजेक्ट्री, ये सब के बारे में कल बात करी जाएगी। ओके, तो ओके, दैट्स ऑल फॉर टुडे। थैंक यू।